Alright, welcome. Okay, let's continue. Previously we learned about this, the pointer, right? Address of operator, something like this. Okay, the reference operator. Alright. Okay. Declaring a pointer. Right. Something like this. These are three declaration of pointer. But in fact, a pointer. Okay. Nevertheless, the data to which they point to do not look okay. All of the pointers, they actually have different type. Okay. Right. Because of the asterisk, we might be confused with the reference operator. Okay. Wait a minute. Okay. No. This is where we left off. Okay. We declare first value and second value as integer type, and then we have my pointer to integer type, and then this one, right? We assign the address of first value to my pointer. Okay, and then we dereference my pointer to give a value to the first value address. Okay, and then we change the pointer, the memory address of my pointer with the address of second value, like this. And then we dereference my pointer to give a value to the address of second value, like this. So when we print out, this is, I guess, specific to C++ rather than C. When we print out, the first value is 10, the second value is 20. I guess, let's try that out. Dmax, okay. What is it? Should I use the holy C, right? The holy C. Okay, and then first value, second value in my pointer, and then my pointer equal to first value, right? Then dereference my pointer. Let's give it 69. and then we change the memory address of my pointer to second value. The reference again 42. Okay, this should be the value for the second value, and the 69 should be the, what is it called, the value of the first value. Let's check that out. First value, first value, first, second, okay, alright. Let's compile the holy C. Holy. Okay. See? 6942. This is what this example, what is it called? Result, I guess. Oh. Okay. Let's go on. Notice that even though neither the first value nor second value are directly set any value in the program, but end up with a value set indirectly through the use of my pointer. Right. This is what it means by indirectly, I guess. Or maybe this one. Yeah, I think this one. The reference and then set the value for the memory address, first value and second value. Okay, this is how it happens. First, my pointer is assigned to the address of first value using the address of operator, right? In this one. So first we assign the address of first value, this one, into the my pointer, right? Then the value pointed to by my pointer is assigned a value of 10. Is this one. So basically we dereference my pointer, and I guess in the previous section, right, they can be used to access the variable they point to directly. Okay, so we are trying to access the value inside the memory address of my pointer and assign a new value. Right. This is the reference of my pointer and assign 10 as the value. Okay. Because at this moment my pointer is pointing to the memory location of first value, because at this moment my pointer is pointing to the memory location of first value, this in fact modifies the value of first value, right? So we are dereferencing my pointer, right, and then assigning a new value instead of using the existing value. Okay. And then in order to demonstrate that a pointer may point to different variable during its lifetime in the program, the example repeats the process with second value. And the same point at the same pointer, my pointer. this one, we replace the address of first value with the address of second value, and then assign 20 to the the dereferencing my pointer. Okay, here's an example a little bit more elaborate. This one 5, first value is 5, second value is 15. This pointer P1, pointer P2. P1 equal address of first value, P2 equal address of second value, right? I mean, I think we can put this in one line, the initialization, I guess. So we can just write pointer P1 equal address of first value, and then pointer P2 equal address of second value. Let's try that after this. Okay. Value pointer by P1 equal 10. Okay. Content value pointed to by P2 equal value pointed to by P1. Okay. Okay, what this means is that with dereferencing P1 and then assign the 10 as the as the value for the address of P1, and then in this one we are dereferencing again, right? We are accessing the value of P1 and then giving that to the P2. Oh no, this is a different one. So because P1 and P2 is pointer, right? So what this means is that we are basically make the address of that we store in the P2 and assign that to the P1. So P2, the address of P2 equal to P1. The address of P1 equal to the address of P2. Not the address of P2, the value, I guess. The value of P1 equal to value of P2. I mean, the pointer value is just a memory address, right? Okay. And then we change again the memory address value that we are storing in this P1. Wait, that's not right, I guess. So maybe there is how do I explain this? we get the value, right? Dereferencing we get the value that the memory address points to, right? And then replace those value that the memory address points to with 20, something like that. Okay, maybe we can try that out again. In first value 5, second second value 15, p1 equal first value, p2 equal second value, and then we're dereferencing p1 and assign a new value that the memory address in p1 points to, which is the memory address of first value 69, and then okay, we are basically dereferencing p1, right? We get the value that the memory address in p1 points to, and then give this value into the p2. So basically we are replacing the value that the memory address points to in p2 with the value that memory address p1 points to. That is a mouthful to explain. Yeah, well, let's try print this first. P2 P1 P2. Okay, all right. Okay, the holiness 69, right? But before this, let's print this like this. Okay. Holy. See, before we do this operation, right? Before we execute this statement, the value that P1 and P2 points to, right, is 5 and 15, and then we change that to 69 and then 69 in this line. Let's continue with this one, right? This is basically make the memory address in P1 the same as memory address in P2. P1, P2. What is it called? P1, you're pointing the pointer, right? Okay. The holiness. Okay. See, and then if we check, right? If we check in this one, it is actually different. This one, right? The memory address stored in the P1 is different from the memory address on the P2 stored on the P2. Something like this, okay. And then we try out this one. we change the, what is it called, the value that memory address in P1 points to with 20, or let's just call it 42, right? And I guess this also change the, what is it, the value in P2. And well, let's also check the value in the first value and second value, right? Not that one. First value, wait. Yeah. First value. Second value. Second value. The holy. Okay. Okay, because we do this, right? Basically, the memory address that is stored in P1 is the same as the memory address stored in P2, which is the second value, right? So basically, P1 and P2 have the second value memory address, and then when we change the value that the memory address of second value point to, is changed to 42, right? So we are only changing the second value and not changing the first value. I think that's basically it. Okay. Comment on how each line could be read. Address of an asterisk by value pointed to by P2. Okay. Maybe this is the proper term. Value pointed to by P2. But the point is that pointer is storing the memory address instead of the, what is it, the actual value, I guess. Notice that there are expressions with pointers P1 and P2, both with and without the reference operator. It is this one, right? The meaning of an expression using the reference operator is very different from one that does not. One that does not. Okay. Yep. When this operator precedes the pointer name, the expression refers to the value being pointed, right? So imagine we have this memory address, right? What this memory address store is the value, wait, before this, I think 16, 9, right? I think this one. Okay. So the value that is stored in this memory address is 69. And then we change that to 42. right? And what this means is that we also change the value of second value, convert it to instead of 69, because this one is actually the memory address for second value. Okay, alright, let's continue. Well, when a pointer names appear without this operator, it refers to the value of the pointer itself. The memory address of what the pointer is pointing to. That is quite mouthful to say. Basically, we are storing the memory address, right? Another thing that may call our attention is this line, right? It's equal to 2 pointer used in the previous example, but notice that there is an asterisk for each pointer, right? This one. In order for both to have the type pointer to in, okay. This is required due to the precedence rule. Right, a pointer is a variable that holds the address of the type indicated. So we are actually not storing the value itself, but we are storing the address instead. Note that if instead the code was like this, right? This means that P1 is a pointer and P2 is not. Okay, P1 would indeed be of type in pointer, but P2 would be type in. Okay. Spaces do not matter at all for this purpose. Spaces do not matter at all for this purpose, but anyway. Yeah, that could be tricky to read. Especially if we put the the asterisk in the type, right? Instead of in the variable. Okay, but anyway, simply remembering to put one asterisk per pointer is enough for most pointer users. Interested in declaring multiple pointers per statement? Okay. Or even better, use a different statement for each variable. Right, so we put this on different line to make it easier to read. Okay, let me copy this in the chat in case anyone wants to see this too. Pointer and arrays. The concept of arrays is related to that of pointer. Okay. In fact, arrays work very much like pointer to their first element. Okay. And actually, an array can always be implicitly converted to the pointer of the proper type. And actually, an array can always be implicitly converted to the pointer of the proper type. For example, these two declarations, okay. In my array 20, alright. In my pointer, okay. The following excitement operation would be valid, okay. Alright. I mean, previously we checked this out in, what is it called? Case price, I guess. Right. I think this one. Let me run the executable. Okay. Right, when this is the, what is it called? This is the array, right? The x is array of char with 5 elements, right? So when we only use x as is, it actually the same as using address of x index 0, like this. Okay, so we are basically assigning, what is it called? Assigning the address of the index 0 of my array into my pointer in, right? Something like that. After that, my pointer and my array will be equivalent and would have very similar properties. The main difference being that my pointer can be assigned a different address, whereas my array can never be assigned anything, and will always represent the same block of 20 elements of type int. Okay, therefore the following assignment would not be valid, right? Because my array will always represent the 20 element of type int, like this one. Let's see an example that means array and pointer. We have this one, right? The numbers array of 5 int, I guess, 5 integer, and then a pointer p, and p as a pointer to int. We assign this, and then I think this can be tricky, right? Especially if we miss the semicolon. Okay, and then we assign the memory address of index 0, the memory address of numbers index 0, right? Like this one, right? This one, but instead of x we are using numbers as the variable name, and then we assign a value to the memory address that points to, I guess, wait, I forgot what's the term, value pointed to pi. Okay, we assign 10 to the value pointed to by p, and then we do p++, right? Increment this one, and then we replace the value points to by p again with 20, right? Okay, maybe let's try this in the code. Okay, is it in num5, right? And then in p. Okay, well, maybe we can put this like this. Okay. Printf. What is it? num0. No, p. Okay. Num. To see if it is the same, right? Then p. Okay. 7FF5ET, right? 12F40. Okay, it's the same. Now let's try this one. Differentiating P and then assign 10 P++, right? Okay, 10 printf, what is it called? P, I guess, the digit P, and then trying to take a look at, I guess, num 0. Not that one. Num 0, right? Okay, and then the holy is then the index 0 of num is also 10. Okay, I mean, if we change it to 1, it should be gibberish. Yeah. Oh, 0, okay. Maybe because of RG, right? I mean, if we didn't declare the number, it will automatically fill with the 0 or the null terminator, something like that. Okay. And then we try P++ to see the value, right? Again, holy, right? Wait. Interesting. P++ is 0. Oh, because, okay, it is not like this. Okay, let's try. It is still 0, okay? Interesting. So we are increasing, I guess, the, what is it called? The pointer address. Right, rather than this, maybe using this. Then 0, we are in index 1 instead. If my hypothesis correct. Okay, right. We are increasing, what is it, the pointer instead of the value. Okay. So we are on the index 1 of num, okay. But yeah, how do we like increasing the value of P? I mean, we previously tried something like this, right? And when we check this one, it is 0, right? Or maybe we should add the, what is it, the bracket like this. Nope, we cannot do that. Okay. Let's check the programming. Increment value plus operator. Wait, I think I've already done that, but where is it? Okay, this is incrementing the pointer. Okay. Like, wait, holy shit. Okay. Oh, right. Okay. My bad. Okay. Right. Okay, interesting. So we need to add the bracket, right? Okay. Where am I come from? I'm from Indonesia. Hello. Welcome. Aditya. Okay. Alright. Let's try. Okay. Oh. Right. Let's try this one. This one is one, right? Okay. The holy. Okay. So we are basically assign value 20 with the, what is it called? With the referencing pre, which previously we, increment the pointer, right? So we are not in the index 0 of num, but we are in the index 1 of num array, right? Okay, that's why this is the same. Okay. Alright, let's continue with this one. Let me go to the toilet for a bit. I'm back. Alright. See you next time, Aditya. Okay. Okay, so let's continue with this one. We are assigning the address of numbers index 2, I guess. The index 2 into the p pointer. Okay. Maybe we can create a separate file for this. Pointer and array. .c, right? Include io.its in main void. Okay. Return 0, right? Alright. Let's compile this again. See. Okay. Now let's compile this pointer and array. Okay. Background pointer and array. Copy that and then pointer and array. Okay. Okay. This is, well, I guess we are kind of following this step, right? Numbers plus 3. Oh, okay. This is quite interesting. Let's find out. What is it? Okay. Num2, right? And then we are doing this 30. Okay. Okay, let's compile this case. Background pointer and array. 30. Okay. Okay, I think this is kind of straightforward, right? And then let's check this. I mean, we already kind of discussed that in the previous session, I guess. But let's try this again. 40. Okay. It should be 3, right? Let's see. Pointer to an array. See. explain this. Let's take a look at this, right? So because num is equal to this one, right? No, not that one. This one. Okay. Num index 0. So basically what this means is that, as far as I understand, we are adding, what is it called? We are adding three more integer. Is that neofim or fim? Oh, this is fim, not neofim. Okay. Print. Okay. Where was I again? Okay. So we are basically like adding three more integer value, I guess, because num is what is it called? The array, right? Array of integer. So it's like we have one integer, two integer, and so on. So this one start at index 0, and then we add another 3. 0, 1, 2, 3. And well, that's the layman term, I guess. So that's why we are actually changing the third index of num. Okay. And now we are in this one. P equal numbers. Oh, again. Plus 450. Interesting. I mean, I don't think that. Did we change the num? Like, let me check. Num pointer. Num. Okay. Compare this and this. Pointer and array. Is still the same, right? With this one. Okay, and now Mr. plus. I'm kind of curious. Request increment operand. Wait, maybe I should do this instead. Wait, why did I close that? Okay. Let's try a value required as increment operand. Alright, okay, we cannot do that. And then let's try this one. I mean, this should be the index 0 again of num. This one, right? Basically something like this. But then we add 4 in this one. Okay. Equal num or 50. I assume this would be the 4, right? Let's find out. Is C my first programming language? No. Actually, my first programming language is Pascal. If anyone ever Pascal programming language. It was back when I was in high school, and I don't really remember anymore about the syntax. So yeah, this is my first programming language. And then, do you recommend people to start programming with C? Well, it depends, I guess. I mean, learning C can be beneficial, like for understanding how the machine works, I guess. Like, for example, currently, okay, let me try to run this first. Like, currently we are talking about memory address, right? So what is it called? What the higher level programming language might not teach us is that we are basically storing all of this information in the memory address, And with C, we kind of need to understand that. Like, variable is, what is it called? Another form of data storage, We are storing data in the variable, and that might not be, what is it called? Explicitly visible in the higher programming language, such as Python, for example, or maybe JavaScript, right? I mean, before I learn C, I learn about JavaScript, about TypeScript, and a little bit of Python, right? So I didn't know about the pointer at all, and it's kind of, It's kind of give me some insight about how the program store things, So I think it is good for the basic, like for the fundamental to start programming. But then, if their goal is, hello, Teja, welcome. But if someone goal is to, let's say, become a web developer, I guess they might learn about JavaScript first instead of C. I mean, again, it depends on what the goal, right? For the general purpose, I feel like C is a good starting point to start learning about programming. But then if you want to dive deep into web or other field that usually use specific programming language, like for example, web development usually using JavaScript or Ruby, right? Then yeah, you might want to start with those programming language, I guess. So it depends. What is your goal? But I think it is, it is not a bad choice to start with C. I mean, like this memory address and stuff, right? We kind of okay. Well, the thing is, C is simple, straightforward, but manual, yes. Yes, that's okay. Thanks for DJ. That's one of the benefit of learning C first, because we are doing things the manual way, right? So it might be easier to move to the higher level programming language when we learn C first, right? It teaches us to do a lot of stuff manually. You could say programming the hard way, right? Okay, but again, it gives us some insight about the memory address, about like this one, the pointer and stuff like that. So we might understand, let's say, when using JavaScript, like what is actually happen under the hood with those JavaScript engine, you know, right? Okay, I guess that's it. Do I recommend people start with C? Okay. From teacher suggestion is choose from the C, C++, Java, because they have strict syntax requirement, right? So we need to learn more about how to do things, right? Like for example, this one. This, we need to use the bracket to increment the value from the pointer 1. You know, I mean, if we just, let's say, something like this, let me write something like this, it actually gives different meaning, you know. Let me compile this and show it. Pointer and array, okay. Which one is it? Okay, I think this one, right? We are in with this syntax, we are increasing the pointer, not increasing the value that p points to, you know. So we need to give the bracket to make this increase from 10 to 11. Let me compile again. Pointer and array, okay, right, like this one. See, a strict syntax requirement. I see you are using Vim to code. Is there any reason for it? Why not use modern code editor like? Okay. Is there any reason? Okay, well, let's take a break, I guess, while I answering that. Is there any reason for it? Okay, so we are talking about editor, right? Finally. Is there a reason not using modern? Okay, first, I start out with, what is it? Notepad++ back when in high school, when I learned about Pascal back then, right? So I start out with Notepad++, and then I try out Dreamweaver, right? And then starting college, I'm trying out this NetBeans, right? And then finally to VS Code, okay? So I've tried out VS Code, and then I feel like VS Code have too much distraction for me. You know, like those bunch of UI stuff in there, bunch of button, and you know, like the mini map in the, what is it called? In the corner, all the stuff. So I get overwhelmed when using VS Code, and then I found out about Vim, right? And I feel like Vim is simpler. I mean, I came out from the Notepad++, which has simple UI, right? So the reason why I stay with Vim, or maybe some people also using NeoVim, is because of the simplicity. Right? I can focus on the code rather than all of those button and UI element in the IDE. That's basically it. I choose simplicity. I guess. I mean, what is it called? Use whatever works for you, right? For me, I like the simplicity of Vim, so that's why I stay with Vim. And if okay, Astrovim, right? Back then there is no Astrovim. Okay, for people who are curious, let's check this. Oh, they changed their name to Astro and Vim now. Back then, yeah, it is called Astrovim. I still remember this. So if you want to start out using Vim without any configuration, you can try out Astrovim, or what is it called? NVChat. This one too. Let me put this in the chat. Or also the, what is it called? The Kickstart, I guess. Kickstart and Vim. This one. Or a minimalist approach, right? I mean, this is NeoVim instead of Vim, and one of the benefits of using NeoVim is, I guess, NeoVim has Lua support, right? So it is less intimidating than the Vim script. Okay, for people who haven't tried Vim script yet, let me take a look at this. Okay. Oh, this is one of the Vim script depending that I use, or maybe possession. This you need to use backslash with Vim script, right? So yeah, it might be more intimidating than Lua. So maybe you want to start out with NeoVim. I mean, I stay with Vim because I've already comfortable. I mean, I tried out NeoVim before and I feel like NeoVim tend to have breaking change, you know. So that's why I moved back to Vim. But hey, maybe when you use this, what is it called? This NeoVim distribution like Astro and Vim and other things, you might have easier time, I guess. But yeah, the thing is there are some key binding change in Astro Vim. In Vim to open folder structure you do, what is it? Backslash comma, but in Astro and Astro Vim I have to some other combination. Oh, yeah, I mean, I guess that's why. Like, what is it called? There might be some difference between the vanilla NeoVim and the what is it, neofilm distribution like this, right? The pre-configure one. So again, I feel like this kind of project like pre-configure neofilm or other things is good to starting out, but it is not the end goal. I feel like this is not the end goal. I mean, back then I used space-film. Space-film, what is it? GitHub, I guess. Okay, I think this one. Back then I used this film distribution. It was way back then. Or maybe this one is more. Okay. Back then I used this. And then I start out building my own film config, you know. Is it beginner friendly? I mean, I guess it's the same as Astro and Film, so it depends, I guess. But yeah, the last update is last year, so I'm not sure if this will work with NeoFilm, but with Film it might be work. Okay, so to answer Yeki SRT, how did you learn to use Film? There is this thing called Film Tutor. Yeah, I can use this to learn Film. So for comment, you get stuck, right? I mean, I feel like if you're starting out, you should at least check Film Tutor like this. There's this SGKL, right? Until it repeats, and so on. It also have a lesson for exiting Film, the important part. I mean, back when I start out using Film, I know how to exit and save and exit, you know, the WQ, right? Colon WQ. But I didn't know how to exit without saving with this one, colon Q exclamation. So every time I'm not sure if I edit something in Film, I need to close my terminal. Yeah. Did I edit some things in this file? I'm not sure. And then I close the terminal and open new terminal and open the file in Film again. Okay, search for comment. If you want to, I don't think I have NeoFilm installed. Yep. But in NeoFilm, I guess there is this tutor comment. Oh, in Film also implemented. Okay. This. So if you open NFilm, right, you can type colon tutor, and you will have the same thing. Yeah, and colon keyboard. In Astro and Film is WQ. Right. W stand for writing. We can check the comment by the help menu. Help and then what is it? Colon W, for example. See, we have this. Write what buffer to the current file, and then we can also How to set up theme for C programming? I'm still not sure. I mean, currently I don't use any like LSP, right? Language server. Wait, let me. LSP. Wait, language server protocol. A lot of people like using this, right? The language server protocol. But currently I didn't use any language server protocol. I'm just using Vim like the default one, except for my own key binding, you know. Like currently I don't even have LSP running for C, so right, starting out with, what is it called? Either with can kickstart and Vim, either with this one or the lazy Vim, what, distro, I guess. This one. Let me copy this in the chat. Still couldn't do it. Oh, okay. So, is there some error message or something like that? I mean, what didn't work? You know. Okay. Yeah, maybe you want to try out this one instead. I mean, it is a one line, if I remember correctly. Only the init Lua, right? And then you can see if this is working as expected or not. I mean, I guess lazy Vim is just too complex at this point. So it's kind of hard to, what is it called? To pinpoint where is the problem, right? So yeah, maybe you can start with kickstart. It is simpler as far as I understand than lazy Vim. I mean, I think kickstart also using lazy Vim package manager. So this may confuse a lot of people, I guess. So there is this lazy Vim, right? This one, and there is also, what is it? Lazy Vim package manager. I think this one, lazy nvim, sorry. This one. Okay, bye. Alright, see you next time. Bye, teacher. Okay, so yeah, there might be some confusion, I guess. Like, lazy Vim is similar to the Astro nvim, but Yeah, and this one is the plugin manager. So, and I think Kickstart also use this one. Let's see. Kickstart also using, let's see, .nvim plugin manager. So that's why. Well, I suggest trying this out first, I guess. For the, what is it? For starting out, right? I mean, I haven't set up my LSP yet. I'm just using the barebone theme. Okay, let me go to the toilet first. Okay, be right back. Don't forget to drink water. Speaking of editor, Kakun editor, I want to try out again using Kakun at some point. Right? I've tried Kakun before, but I feel like I didn't give Kakun enough time, you know. In case anyone curious, it is, you could say, the alternative for modal text editor other than Vim. If you want to check this out, okay. Alright, let's do you have job or are you a student? Okay, so I'm currently on career break. I mean, I previously have a job, right? So, and I'm working as a web developer at that time, and I feel like I want to try out becoming a system developer, something like that, handling this low-level stuff, right? That's why I'm starting out this, what is it, this journey, you know, like learning C, and then after this I'm trying out programming from the ground up, if you ever heard of this. Where is it? I think this one, right? Okay. To learn more about how the memory works and how the CPU handle things, other stuff. So yeah, I'm currently on career break to change my career, I guess, from web developer to hopefully a system developer job. Okay, let me copy this again in the chat. I have finished college. Yes, I've already finished college. But at that time, I don't really, what is it called? I don't really going deep into the programming side of things. So yeah, I've already finished my college degree. Okay, let's continue. Okay, we are like this, right? Then we plus 4 like this. That is interesting. Right? No, not that one. Enam, okay. Okay, playground, pointer, and array. Alright, 11. Oh, but it is 50. Alright, interesting. This is... You are interesting person. Well, thank you. Okay, hope you enjoy your stay. Okay. 11, right. So when we were printing this, we were printing 11. So let's check like this one. Plus 4. Okay. Compile this and then pointer. Okay. Alright, so it seems like there is a difference. I only do live stream. For now, yes. I only do live stream. But well, maybe if I have some short-term content, I make a short form video, I guess. But for now, yeah, I'm doing live stream. Okay, P plus 4. Right. So what is the difference between this one and like this one? P plus 4. Can we like do this, for example? Nope, we cannot do that. Okay. But I think we can do this, right? No, okay. Alright. So this is assignment, I guess. P plus plus. Okay. If I do this, it should be the same. Hey, no. that one pointer and array. Okay. Did we like change background? Oh, I usually live streaming around 10 a.m. So if you want to join, maybe you can join around that time. Okay. See you next time, I guess. Pointer and array. Okay. Oh, we didn't increase that. Okay. Yep, it should be something like this, right? Okay, so this one playground pointer and array. Okay, like this one. So basically this means that we are dereferencing the, what is it called? The 0 plus 4 index, right? So that's why we are on the 4th index. What time is on your country? Right now? Right now is 12 p.m. I guess. Oh, wait, let me type. UTC plus 7. Maybe that's what you mean. My time zone is UTC plus 7. Okay, interesting. P plus 4. Okay. Let's add a comment, I guess. P plus 4 in here means that we are the main difference being that pointer can be assigned while arrays cannot. Okay, bracket and specifying the index of an element of the array. Well, in fact, these brackets are the referencing operator known as offset operator. We're explaining as specifying the index of. In fact, these brackets are the referencing operator known as offset operator. Oh, okay. Okay, this is interesting. Okay, offset operator. They reference the variable they follow just as asterisk does, but they also add the number between brackets to the address being the references. Okay. This is interesting. Let me add a comment here. Bracket like can mean differencing, can mean operator, offset operator, for example, differencing operator known as offset. Basically, this means that we dereferencing that we are dereferencing the pointer, I guess, with the number of with the offset provided. I mean, this kind of make me curious, you know. Can we do like this, for example? Okay, what is it called? B and then 0. I'm not sure if we can do that, but let's find out. Pointer and array. Oh, interesting. We have pin equal num, right? It is num equal to the, what is it? Index 0. But okay, so I want to try this out in, let's say, enu69 pointer itu enu, right? Can we like using this? No, itu. Let's find out. It compile at least pointer and array. Oh, we can. Wow. Interesting. Okay. Even though itu is not an array, right? We can do this. This is interesting. With the offset profile. I mean, if we increase this by 1, I think we will get a segfault. Let's find out. We got gibberish. Okay, right. This is quite interesting. So when we have we have num 5, right? Not only if A is a pointer, we are dereferencing the pointer with the offset provided. We are dereferencing the offset. The pointer num the pointer num known as offset operator. Referencing. Let me put this. Okay, reference. Okay, if num 5, we are referencing the pointer num with offset 5. It's similar to this one, num plus 5, right? Plus 4. Okay, what are we making here? Okay, currently I'm following this book, right? Put Your Own Lisp. Let me copy in the chat. So basically I want to learn C by building a Lisp interpreter, a simple Lisp interpreter, like let me show you something like this, right? So it's kind of the same as Python, I guess, but it is probably not gonna as advanced as Python. So yeah, basically this is the goal, creating a simple interpreter. And currently we are, what is it called? We are trying to learn about pointer, you know. Let me copy this in the chat. So the point is to learn C, right? The point is to learn C, and this book provides a guidance with, what is it called? To develop a Lisp interpreter, right? So I'm trying to learn C by building Lisp interpreter with this book guidance. Oh, okay. right. Python I never learned. I'm actually never learned Perl and PHP, but Python is, well, I don't really use Python that much too, I guess. So yeah, I don't really, I'm not sure if I can explain that, but it's basically just another programming language. Okay, and hey, no one is older, you know. Like, we are still young, right? We still have enough time to explore other things. Okay, it's similar to okay, let me compare this. Yeah, currently I'm trying to figure out about pointer, and it's quite interesting. Yeah, we're not talking about it. Okay. So we're currently exploring about a pointer, and I found out something interesting. Pointer are really nice. I mean, it can be confusing at times, you know. Like for example, this line, right? I'm basically trying out. I just found out that brackets is mean offset operator, right? So even though the E2 variable is not an array, but I just found out that we can do this using the bracket. Well, let me run this case. Right. Can also dereference E2 pointer with the bracket. It's kind of interesting, I guess. The struct object yet is I've tried, what is it called? I've tried making some struct, I guess, but I haven't dived deep into struct yet, like this one. Struct an object, others do not. Oh, okay. Wait, maybe we can start from the object first, I guess. I mean, I feel like the object, what is it called, can have different meaning depending on the programming language, I guess. Programming, what is object, right? I mean, in JavaScript, object is like this, like a JSON or something like this. In JavaScript, something like this, object. So okay, seems like I'm doing stuff correctly. Okay, I'm kind of curious. What is correctly in here means, is using type def. What you mean by not the correct one, or yeah, I mean, I'm still not sure, right? There are some people who like using type def like this, right? And I feel like using it like this kind of heighten the meaning, you know, like heighten the information that this is struct, right? So I'm not sure which one is correct. So that's why I use something like this, struct alpha, and then explicitly typing the struct like this, struct alpha, Yeah. It's whatever you're comfortable with. Okay. Alright. Okay, so I'm kind of curious about object, I guess. From statement 2. Yeah, is object similar to Wait. One can get keyboard input back in C. They pass the struct to the function using a pointer. Pass the struct to the function using a pointer. Oh. Is this what you mean? Pass the struct to the pointer to the function using a pointer? We have value pointer and then struct file, right? But yeah, keyboard input back in C. Okay. I think keyboard input using what is it called? The scanf, I guess. If I remember correctly, I think there is this scanf where we can get the keyboard input. Oh, okay. Oh, alright. Yeah, I mean, I'm still like experienced, right? So I'm still not sure what is correct or what is incorrect, I guess. So, okay, let me check. Okay, maybe we should go to the pointer first. Like this one, right? We are trying this out. And oh no, not that one. Hold on a minute. We are trying this out, but yeah, I don't really print out all of it at once using for loop. Okay, this is actually interesting. I didn't know previously that bracket is a part of the referencing operator, as known as offset operator. I thought that we are just accessing the index of an element of array. Some to allow can F but others to F gets. Oh, okay. Get is deprecated and never use gets ever. Okay, thank you for the information. Then some parse out the enter at the end. Oh, okay. Alright. I mean, for the input for our interpreter, we are using, where is it? We are using readline currently. So yeah, we are not really using scanf or fgets. We are using readline. And I'm kind of curious, like, can we make a simplified readline? Yeah, maybe next time. I mean, I want to focus on learning this first, learning about pointer first. Currently, they reference the variable they follow just as asterisk does, but they also add the number between brackets to the address typing the reference. Okay, this is quite fascinating, I guess. Like, this one is referencing too. Interesting. And the result is the same. Are equivalent and valid not only if A is a pointer, but also if A is an array, right? Previously we tried this out, right? Like using E2 pointer and using the bracket to access the value, to dereferencing the E2, what is it called? The E2 pointer. Previously I didn't know about that. Interesting. Not only if A is a pointer, but also A is an array. If an array, its name can be used just like a pointer to its first element. Okay. If an array, its name can be used. So for example, this one A, you can just typing A and it can be used like the pointer to its first element. And well, like previously we check on this case price challenge. Let me open this. For anyone interested, I guess. Let me copy this in the chat. Wait. So we basically have this kind of pointer challenge, and we learned that this one is different than this one. It's like we are having the entire array in this %x, and then adding those by, what is it called? By the size of the actual array. So imagine that we have this 5 char, and then we adding that by 1, 5 char again, and then 5 char again. I think let me show that. Like, where is it? Like this one. We have, what is it called? We have 5 elements of char, right? And we add that by 1. So it's basically 5 char and then another 5 char. This is the first address of the another 5 char, right? Which is equivalent to the index 5, which didn't really exist. Okay, or didn't really have a location, I guess. And then we puts function with puts function. Oh, right. Okay, I'm kind of curious though. Is there any difference between puts and printf? I think, yeah. At the beginning, I try using puts too. The only difference I know is that printf have the, what is it called? The format specifier. So we can specify this like integer, something like that, I guess. Okay, so if we press 2, right, it's like we are accessing the memory address of the 10, what is it, the 10 index. Okay, alright. say it this one. Let me add comment first. This, what is it? This is an example of dereferencing a pointer with brackets. Okay. Okay. Pointer initialization. Bots will only do char array, so everything else will be printf. Okay. Alright. Okay, pointer initialization can be initialized to point to specific location at the very moment they are defined. The resulting state of variable as after the resulting state of variable after this code is the same as after pointer can be initialized to point to specific location at the very moment they are defined. Okay, like this one. Okay. Oh, this is equivalent. This one is equivalent as this one. Okay. I think put C or put char works depending upon the compiler for individual char variable. Oh. Okay. Yeah, I only know that put char only print out a character. Okay, it will end the array of char with new line. Okay. The resetting state of variable after this code is the same as after. Okay. Basically, this is equivalent to this one, right? When pointers are initialized, what is initialized is the address they point to. My PTR. Okay. Never the value being pointed. Okay. This one, right? They point to initialize the address instead of the value being pointed to. Okay. Therefore, the code above shall not be confused with this one. Okay. And it would not make much more would not make much sense, and it's not a valid code. Okay. The asterisk in the pointer declaration line 2, this one only indicates that it is a pointer. It is not the reference operator as in line 3, right? I mean, some people might get confused. I mean, previously I'm also get confused, right? It turns out that this is dereferencing, not really assignment or declaring a pointer like this one. Okay. It will enter array of char with new line as in a different line. That is correct. Okay. You really like the pointers being everywhere. I mean, well, there is some benefit using pointer, right? but it can be a lot tricky when we use pointer. Okay. No, it's okay. I mean, I'm doing this live stream so we can learn together, So if you have any input or any reference, please be free to say that in the chat. I mean, what I say might not be correct, right? Because I don't really have any experience with C, so maybe I misunderstood something, Okay, the asterisk in the pointer, okay. That it is a pointer, it is not the reference operator. But things just happen to use the same sign. It's asterisk. As always, spaces are not relevant and never change the meaning of an expression. Okay. Pointer can be initialized either to the address of a variable, such as in the case above, oh, okay, this is new. A char not always a byte. In UTF-16, it will be 2 bytes. Okay. Let's take a look. I never try UTF-16. That is interesting. 16 what text, I guess. Yeah, I only knew about UTF-8. Alright, why the need for UTF-8? Is there any use case for using UTF-16? So minimum every software developer. Oh, okay. Minimum every software absolutely positively must know about Unicode and character sets. Excuses. Okay, let me copy this in the chat. Okay, this is interesting. Let me go to the. If you have a larger alphabet character than just English. Oh, okay. Wait, let me go to the toilet for a bit. Be right back. I am back. Okay, for example, if we are dealing with Chinese, Japanese, it will be 16-bit. Oh, okay. Or UTF-32. Interesting. That use. Okay. Yeah. I didn't know about that. Thank you for the information. That is interesting. Very John. Okay, let's say. Oh. The official Unicode. Oh, okay. It won't affect insert long float. It will only influence char variable. Okay. Well, previously I thought that we can use, what is it called? We can use char bit, I guess, to see how many bits we have in one byte. But I guess this might be different if we have UTF-16. Interesting. Okay, depending on the encoding form, UTF-32, okay. Let me copy this in the chat for those interested in more than one way. 148-bit byte, a single 32-bit code unit. Okay. Encode transformation format. Alright. Where can I get more information on encoding forms? Okay, interesting. In the not too early days, all that exists was ASCII. Okay. Okay. Unfortunately, to this strange world. Okay. Global intercommunication and social media was not foreseen. Okay. And it is not too unusual to see English. Okay, right. In the same document. I hope I didn't break any other. Well, fortunately, my browser handled that fine. So you have to malloc the char variable whenever you're getting character input. Whenever you're getting. Oh, okay. Alright. A character input, right? So I mean, what is it called? What you mean by character input is like when we are using scanf, something like this, or maybe like something like this. My jar, something. I mean, do we need malloc to assign the jar like this, or maybe I guess something like this, right? My jar, let's say. Do we need to use malloc? Because in my implementation, where is it? Alpha R, right? We're basically providing, what is it called? The string literal directly, right? But the function itself did not use malloc. I'm just pointing the character directly. Oh, okay. Alright. Okay. Alright. Okay, let's continue. Oh, I just remember we're using the bracket here. Maybe we can refactor that later on. To refactor to not use I'm trying to what is it called, having a consistent syntax, I guess. I mean, I'm following the, what is it called, Linux kernel coding style. So, well, maybe we can do that right now. Like this. Maybe we will read this on the next session, or after I reading about this pointer stuff. Okay. Alright. Pointer either to the address of a variable, as in the case above, or to the value of another pointer. Okay, like this one, right? Okay, pointer arithmetic, this one. That kind of tricky, I guess. To conduct arithmetical operation. Conduct arithmetical operation on pointers is a little different than to conduct them on regular integer types. Okay. To begin with, oh, wait a minute. Well, let's take a break first. And then, do I have if okay. Right. Oh. The macro did not work as expected. My film macro. Doing some kind of refactoring here. Wait a minute. Where is it? I think I already checked everything, right? Since I'm okay. Numerically for single character. Wait. Hold on a minute. String CMP, the single character. Oh, is it this one? After to just check numerically. Okay. Yeah, I didn't know about that. Okay. You can just check the char value. Oh. Okay. S0. Wait. I mean, maybe the compiler optimized that. But yeah. Okay, yeah. Calling a function means we have to push a new stack frame. Okay. I mean, yeah, I just start out using C, so I didn't realize about that. Maybe I got my char is thank you char I mean, this is interesting, you know, like check the character numerically. Let me understand that. I mean, I guess the reason we are using string GMP is because, what is it called? Oh, but yeah, we are only checking one character, right? Okay. I think we can refactor this, right? Like something like this, maybe. Is this correct? Make it single quote, okay. Alright. Yeah, I didn't realize that. Okay. Something like this, make it single quote, okay. And then this one too. Maybe we can create, okay. Make it single quote. Alright. Sync this one, okay. Alright. Now let's try that out. Let me know. Okay. Oh, right. Yeah. I forgot to delete this one. Okay. Okay. Let's try this out. 69. Okay. Negative 71. Okay. Then string GMP str1 str2 return sum str1i for all e. Oh1. Okay. And what theme plugin is that showing the purple thing? Oh, the jump in the code. Okay. It is actually called film sneak. This one is called film sneak. Let me copy this in the chat. I mean, I guess there are a lot of variation. This one, the related, either AC motion, small or quiver F. But the one I use is this film sneak. Okay, interesting. Let me I mean, I've tried using new theme before, you know, and I've moved back to theme because I feel like new theme have a lot of breaking change with the newest release. So yeah, I'm like, let's just using theme instead. first let's commit. Is it called? No, not that one. Not that one. This one, right? Okay. Wait, we're basically okay. Wait, git commit char utils and not char refactor, I guess. Remove brackets in one line if statement. Trying to follow Linux kernel coding style which did not use. If we only have one statement in the if condition, something like this. If we only have one statement in that. Okay. And then refactor this one. Git commit refactor reduce np string gmp with what is it called? Normal comparison. Normal comparison in one char. Okay. Just realized that we don't need change mp to reset. We don't. Udah berapa lama ngoding? Oke, berapa lama ya? Mungkin sekitar 4 tahun. Ya aku nggak terlalu ngitung sih. I don't really calculate how much time I spend in doing programming. Just realized that to check only one character. How do we explain this? To check only one character in the for should parser state 8. And put in okay. It's just a step. Arithmetic operator in built-in. Wait. I think rather than using the bracket, maybe we can use the asterisk instead, right? Make it easier to understand, I guess. Let me record the macro. Okay. It should be the same, right? And let's find out. Clips 69, okay. Alright. Okay, thanks to Timo for the suggestion. Okay. Add this one. Git commit amend. No edit. Okay. Alright. Okay. Let us continue with this pointer arithmetic. To conduct arithmetical operation on pointers is a little different than to conduct them on regular integer types. Okay. To begin with, only addition and subtraction operation are allowed. Only addition and subtraction operation are allowed. The others make no sense in the word of pointer. Okay, but both addition and subtraction have a slightly different behavior with pointers according to the size of the data type to which they point to. Okay, so when we use addition and subtraction with pointer, the behavior can differ depending on the size of the data type. Okay. When fundamental data types were introduced, we saw that types have different size. Okay. For example, char always have a size of 1 byte, but well, according to Megaman, there's a case that we have UTF-16, which makes char have 2 bytes instead of 1, which can be interesting. Okay, so we need to keep that in mind, I guess. Okay, sort is generally larger than that. And in and long are even larger. Okay. The exact size of this being dependent on the system. Right. Okay. For example, let's imagine that in a given system char takes 1 byte, so takes 2 byte. Well, let me add information first. Char overflow, I guess. Where is it? 64-bit system with char has 1 byte size. Okay, something like this. Adding an information. Char utils info about char size in char overflow checker. Just learn that char size can be bigger than 1 byte if we are not using the f8. For example, when we use UTF-16, char size can be 2 bytes. 2 bytes instead of 1 byte. It is interesting. Okay, so long even larger. Okay, the exact size of this being dependent on the system. Okay, in a given system, char takes 1 byte, short takes 2 byte, and long takes 4 byte. Suppose now that we define 3 pointers in this compiler. Char, my char, okay, short, my short, and long, my long. And that we know that they point to the memory location. Okay, this one, 1000, 2000, and then 3000 respectively. Therefore, if we write this one, my char as one would expect would contain the value 1001, but not so obviously. My short would contain the value 2002, and my long would contain 2004, even though they have each been incremented only once. Okay. The reason is that when adding 1 to a pointer, the pointer is made to point to the following element of the same type. For the size in bytes of the type it points to is added to the pointer. Okay. Okay, let me type this in the case place. Where is it? This one, right? adding 1 to a pointer. Or maybe we are using this in here. Oh, right. For those who just joined, I just learned that we can use bracket, the square brackets, square brackets, I guess. And then this one, right? Okay. Okay, the offset. We can use square bracket like a differencing the pointer with the offset. So for example, we have this pointer to integer type, right? The E2. Instead of using the usual dereference like this, we can also using the square bracket like this one. It is kind of interesting. I didn't know about that before. So at least we learn something new, right? Or I learned something new in case you didn't know about that. Okay. The reason is that when adding 1 to a pointer, okay, let's check this out. Char, my char, and then char, what is it called? Short. Okay, and then this one short, long. Okay. And now we use plus plus like this one. Okay. I mean, yeah, there is a difference, right? Plus plus at the front and at the back. Okay, so my char like this, I guess. Should we print out the pointer, or maybe we should print out the integer representation of the pointer? Let's find out. My char, right? And then this one, okay, and then this one. The moment of truth, playground, pointer and array. Okay, 1, 2, 8. Oh, like interesting. Wait. Oh, wait. So why like 1 to 8? I mean, like, should we, is it called? Should we do something like this? Okay. And then print out something like this. Playground, pointer and array. Still the same. Interesting. Pointer and array. Okay. That is interesting. By 2 by 8. Wait. Like, what is it called? My char, right? I think this is 0, you know. Pointer and array, okay. See, this is 0. So, okay, char and then short and then long, sorry. Compile again. 0. Okay. I guess that's why, right? Plus. That's why when we are using this, it actually no. Playground, pointer and array. Man, how is the journey going? Okay, so currently we are trying to learn about the pointer arithmetics. This one, let me copy this in the chat. So I'm trying to learn about pointer because in this book we are at the chapter 11, this one, and in this chapter 11 there's this section called function pointer. So that's why I want to learn more about pointer before going deep into this section. Oh, hello, welcome. I don't really understand what is it called, the YouTube algorithm, so welcome. I hope you enjoy this day. Currently we are checking out the pointer arithmetics. For the context, I'm trying to learn C, right, by following this book, Build Your Own Lisp. We are basically trying to put a simple Lisp interpreter. If you didn't know about Lisp is basically a programming language like C, right? This one. Let me copy this in the chat. So Lisp is basically a programming language, and we are trying to create something like, let's say, a Python, a simplified version, not as is, you know. This is what we are creating so far, right? We are creating an interpreter that use Lisp syntax, you know, because I want to learn C. The point is to learn C, you know. So I'm trying out malloc and of the stuff, And because we are in the chapter 11, and in this chapter 11 we talk about function pointer, I want to kind of revisit, I guess, or maybe going deep into the pointer in the pointer, what is it called? In the pointer definition? No, I think that's not the word. Anyway, I want to learn more about the pointer. That's the point. So yeah, currently we are checking out the pointer arithmetics. Like we have this declaration, right? Pointer char, pointer short, pointer long. And if we do this plus operation, right, we are actually having different result, Assume that the pointer char have value 1000, and then pointer short have value 2000, and then pointer long have value 3000, right? So when we do this kind of arithmetics, okay, I have tried to learn coding from a book. Guess it was Django, but I ended up just writing the same code in the book. And when I tried making a project, okay, and that's what we do differently in here. I didn't follow what is it called? I didn't follow the instruction as is. I'm exploring what can be done. For example, like this one, right? We are using type def, but in my implementation, we are not using a type def, but we are using the struct. Wait a minute. We are using the struct. I think it was in the, let me cross check. It was in the chapter 6, I guess. Oh no, not chapter 6, or maybe chapter 9. See, the book using type def struct L file, something like this. But in my implementation, I'm using struct, not using type def. So the challenge is that how can I translate this line to fit my own implementation without the type def, I'm trying to differ from the book, right? And that's why I'm trying to understand about the function pointer, and maybe trying to understand more about the pointer itself, right? So I'm not following the book as is, and I guess I always make this as a joke, right? We are actually rarely taking a look at the book. I'm just going off on my own most of the time, So, and if you take a look, right, we are on the part 86 or maybe 87. I don't really remember at this point. Yeah, we are more than 80 sessions in the learning of this book, right? But we are still in the chapter 11, and there is still more chapter going ahead, right? So yeah, I'm actually rarely looking at the book, and I'm just looking at the book to find out the unknown, like what I didn't know before. For example, in this case, the function pointer. What is the function pointer? And then I found out that it turns out the function, I think I can demonstrate that in the Holy C here. Let's run this code, the Holy C, right? It turns out the function itself has a memory address, So, as far as I understand, at least for now, so we can do something like this. This one, we have add function, right? And then we can assign the memory address of add function into the function pointer fptr, and then using fptr like the add function. That's basically it. As far as I understand for now, at least. Function pointer. See. So I'm only reading the book just to find out the unknown, what I didn't understand previously, or I didn't know at all, I guess. And then going on my own, like reading this, what is it called, tutorial, I guess. So if you don't even look at the book that much, so you already know, see, no, it's quite the opposite. I didn't know about C at all when starting out reading this book. So what is it called? I'm searching another reference other than this book to explain me what is going on. That's basically it. I mean, I didn't want to be trapped in the, what is it called? In the tutorial hell, right? Like, we are just following the tutorial as is, and we have no idea what's going on. So this is what I'm trying to do. Previously, if you take a look at my, what is it called? In my previous session, I didn't even know how to write struct, I get a syntax error all the time when trying to compile this line of code for the first time. Because what is it called? Because the book using type def, right? The book using type def like this. So when I'm trying to use something without the type def, at first I think I do it something like this. Oh, sorry. Maybe something like this, right? And then I try out something like this, struct, and then the name at the end, right? It turns out that's not the case. So yeah, I learn one by one. So I get a lot of error to put it simply. Okay, so how would you recommend me be my approach to learn Django? I mean, okay. First thing first, rather than following the book as is, I mean, we're talking about learning Django, right? Which personally, I don't really have any experience using Django. So my general advice is start from changing the variable name, For example, like, let's take a look at this, I guess in chapter 9. Where is it? Let me take a look. Changing the variable name like this one, for example. Instead of using x, try to use another variable name. like value or maybe y or something else. Because if we are just following this as is, like we don't really analyze what this mean. For example, in my case, alpha num, right? I'm using the num as the variable name or as the parameter, the function parameter instead of x. So when I have some problem, I need to translate this code, this line of code, into what my implementation looks like. Something like this. What is it called? Alpha num. Yeah, something like this. So I don't use x, I use num. So what is difference, right? This is x, okay, this is x. So I need to put num in here and also in here. So we are a little analyzing the code a little bit from that. And then maybe you can also change the type too, or you can try your idea, but in my opinion, start from changing the variable name. Because if we are just using it as is, well, we might not realize what is the problem. We might not analyzing the code. Like, okay, we have x here. Where do we have x again? Oh, we have x in here too. So we need to put what we change in here in this line too. I think start from there and then take a look at the, what is it called? At the reference that you didn't understand. For example, currently we are in this, right? In this chapter 11, and I'm curious about function pointer. So I take a look at this tutorial about pointer and trying to understand more about pointer, right? So I guess that's my recommendation to start out when you reading a book or following a tutorial. Next, try to change something, even the variable name, because when we change the variable name, we unconsciously need to analyze what's going on. What is the difference? And I guess that's my approach too, I didn't follow the book as is. And now I have another challenge, right? How can I translate this line into something that fit in my implementation? Because I don't use type def, I use struct. So yeah, that's why I'm currently trying to find more information about pointer so I can tackle this challenge, right? I mean, okay, I hope that helps. I mean, I'm also still learning, right? So maybe anyone have another suggestion? Okay, but yeah, that's how I learn things, I guess. Like for example, I didn't use my char like this. I use my underscore char in, wait a minute, where is it? I use my underscore char as my variable name, just so I can analyze what's going on. Okay, we have this my char, and I change this to my underscore char, and now I need to, I also need to change this too. and then I take a look at my implementation. Oh, my char is actually a pointer to char, right? Okay, and then start from there, analyze, what is it called, the analyzing process, I guess. So yeah, I try not to follow the tutorial as is, but change a little bit, like a variable, or change the, what is it called, the value itself, right? For example, I just realized that the square bracket, the square bracket that a lot of programming languages say that it is, what is it called, accessing the index of the array, is actually some kind of dereferencing operation, So when we have a pointer like this, let's say we have a variable nu, right, with value 69, and we assign the memory address of variable nu to pointer itu, right, we can dereference the value using square bracket like this. I mean, I don't know about you, but I didn't know about that before, So it's kind of interesting, right? And then we get 69. It is, I guess, the same like we are using this. Let me change this. And let me compile this again. Okay. Right, it is the same. I didn't know about that before. Even though itu is not an array, but we can access the index 0 of it. Okay, so that's my suggestion. Just start from changing the variable name, and then start changing anything else from there. At least try not to use the same variable name with the book or the tutorial that we are following, Okay, let's continue this one. One would expect would contain the value, okay, but not so obviously. My sort, in my case, my underscore sort, right, would contain the value 2002. Okay, and my long would contain 2004. Alright, even though they have each been incremented only once, the reason is that when adding one to a pointer, the pointer is made to point to the following element of the same type. Okay, let me this will print different result, right? Because okay, oh, maybe another suggestion, we can also try to explain what we learn or what we type in the code. Like for example, this one, I'm trying to explain what is going on in this line of code, because by explaining things we might learn what we don't understand too, Okay, the reason is that when adding one to a pointer, the pointer is made to point to the following element of the same type. following element of the same type. Okay, because by adding the number to a pointer, we made the pointer to point to we made the pointer following the pointer points to the following elements of the same type. The same type, right? Okay. The same type, which in this case the bytes of the size the size of the type in bytes. Okay. This will print different result because by adding the number to a pointer, we made the pointer points to the following element of the same type. Let's, I guess, underscore this. Following elements of the same type. In this case, represent the size. Represent the size of the type in bytes. Okay, because short is 2, right? 2000, 2001, 2002, and then long is 4. 1, 2, 3, 4. Okay. By adding the number to a pointer, we made points to the following element of the same type. And in this case, represented is represented as what is the word here? Is represented as the size of the type in bytes, I guess. I don't think that is right. To get the following element, following element, we depends on the size of the size of the type. As we can get with size of operator. In this case is okay. The following element of the same type with size of operator. Okay. I mean, if we take a look, previously we have the 0 value, right? And because char type in my system have 1 byte, it become 1, and short become 2 because of 2 byte, and long. Oh, long actually is 8. Interesting. I don't. Oh, this one. Long bit, huh? Interesting. Okay. Yeah, I didn't know how many byte long is. It's quite interesting. I mean, I guess we can take a look at what is it called? Long size of long, right? Okay, playground pointer. Okay, yep. The size of long is 8. Okay. That is interesting. This is the representation, right? We have 1000 and then we increment by 1 because char is 1 byte, right? And then in the sort, we increment by 2 because sort is 2 bytes from this, what is it called? This assumption, right? Char takes 1 byte, short takes 2 bytes, and long takes 4 bytes. Okay. And then this is long, my long, 3000, and then increment by 4. So it become, what is it? 2004. This is applicable with. Okay, this is applicable both when adding and subtracting any number to a pointer. It would happen exactly the same if we wrote okay. Right. This is kind of the same with this one. Regarding the increment and decrement operators, they both can be used as either prefix or suffix of an expression, with a slight difference in behavior. Okay, as a prefix, the increment happens before the expression is evaluated. As a suffix, the increment happens after the expression is evaluated. This means something like this one. Plus my char and this one, my char plus. There's a difference. In this one, as far as I understand, we are actually increment the value first and then evaluating the value of my char. But in this one, we are evaluating the value of my char first and then increment after that, after the evaluation. So this one will get us the, what is it called, the new value, I guess, get us the new value, and this one will get us the current value. And I think we can try that in here. Let's see. Okay, compiling. Okay, see, because we are using mychar plus plus, now the variable plus plus mychar, this line, I mean, is 0 instead of 1. That's basically what this statement means. As prefix and as suffix. Okay. This also applies to expression incrementing and decrementing pointers, which can become part of more complicated expression that also includes the reference operator. Okay, remember operator precedence rule. We can recall that postfix operator, such as increment and decrement, have higher precedence than prefix operator. So, okay. Operator precedence rule. Postfix operator, increment and decrement, have higher precedence than prefix operators, such as the reference. Okay, I mean, I think this is the one we encountered before, right? Previously we try out this one. Okay, I think this one. Okay, previously we try out this one, and I'm kind of confused, right? Why are we incrementing the, what is it called, the pointer, rather than incrementing the value, you know? At first I thought that we are dereferencing first, and then we are increment the value, in this case 10, right? But it turns out that's not the case. It turns out we are increment the pointer first, and then we dereference the pointer after the increment. So we need to use the bracket like this one to tell, what is it called, the compiler, to tell the program to dereference first and then increment the value of the dereference, then increment the value. So it becomes something like this, 11, right? And I think I can show this, compile this, playground, pointer, and array, right? It becomes 0, and the num index 0 still 10 instead of this one, right? So that is why I got confused previously. And then this one, it turns out there's this operator precedence, right? Operator precedence rule. Let me the bracket around because of operator precedence rule. Precedence rules which evaluate the plus operator first and then postfix. Oh, this is called postfix. Okay, interesting. Okay, let postfix operator plus operator first and then where is it? And then evaluate and then the reference the pointer. We need to bracket around pointer P because operator precedence rules which assign which make the postfix operator a higher priority than the reference operator. Because of operator precedence rules which make the postfix operator like a higher priority if we don't provide the bracket around the reference P. Or maybe something like this. Operator rules make the postfix operator a higher priority than maybe something like this. Around precedence rule, the postfix operator like then the reference operator. Is equivalent to okay. That's why the expression is equivalent to B++. Increase the value of B, so it now points to the next element. But because of plus is used as postfix, the expression is evaluated as the value pointed by the pointer that it point to before being increment. Okay. Value pointed originally by the pointer. Essentially, these are the four possible combinations of the dereference operator with both the prefix and suffix version of the increment operator. The same thing applicable to the decrement operator. Okay, same as this one, right? Oh, okay. It's also the same. Whether we put the, what is it called? The postfix operator or the increment operator before P. Okay. Oh. I can do this. Dereference the pointer first, and then increment the value. Okay. And increment the value it points to. I guess, yeah, this can be misleading. I guess this can lead to a lot of confusion. Okay. The typical but not so simple statement involving this operator is okay. Well, okay. Plus has a higher precedence than pointer. Both P and Q are incremented, but because both increment operator are used as postfix and not prefix, the value assigned to pointer P is pointer Q before both P and Q are incremented. Oh, okay. So this means that okay, interesting. The P is pointer key. The pointer, okay. The reference P is the reference key before both P and Q are increment. So the current yeah, this is kind of this is kind of confusing, right? I mean, let's say we also have this one, okay? num 2, I guess. Other than num, maybe we can do this one. This is okay. B plus plus. And then increment afterward. Interesting. Wait. Let me think how we can represent that. Plus equal plus, right? I mean, yeah, why is it different, right? When using it like this. So we are actually not increasing the pointer, huh? Okay. Okay. Let's compile that. An array segfault. We got a segfault. Interesting. Maybe also num1, I guess. Right. Square bracket can mean dereferencing with the offset, okay? Okay. A14, huh? Oh, this is interesting. Okay. Well, I guess we will continue this on the next session. So that's it for now. See you next time. Bye bye.